Hello, beautifuls. This is Atleen, and welcome back to my channel. So tonight we will be discussing the IPv4 subnetting overview, and this is part 3. So let's say that our router has a ton of route entries that's trying to store, is overwhelmed, multi-layer switches as well. They might have a lot of entries, or you don't want them to advertise that much to their neighbors because that's a lot of traffic. So, what if you took a bunch of networks that have a lot in common, like the ones on the screen? We got 192.168.1.0, 192.168.14.0, 192.168.20, what's that, 25.0, 192.168.1.30.0. And instead of advertising those individually with our routing protocol saying, here's this one and here's the next one. If we look at this in binary, now we know that the first octet, as you can see on the screen, is going to be on the same 192. And then the second octet is 168. With the third octet, we might have some bits. They're not the same numbers, as you can see. The third octet, we have 1, 14, 25, and 30. So it's going to be differences in there. But let's see if we can have any in common, any bits in common. If we write those numbers in binary, that octet 3 you see on the screen, the first 3 bits are all zeros. So all 4 of these networks, they've got the first 19 bits in common. So instead of advertising 4 individual networks, what if we instead advertise one network with a /19 subnet mask? That would include all these networks when a router that receives this try to get to an IP address. It's just saying, do I have a route in my routing table that encompasses the IP address I'm trying to reach? Yes, that would include IP addresses in all 4 of these networks. We're just advertising it at one time, just one at a time. So what do we do? What we do is we take those 19 bits and we say that's going to be our subnet mask because we've got 19 bits in common. So I put in 19 ones in my subnet mask and I put in 13 zeros. Let's now convert that to decimal. The first octet to decimal, we're going to decimal, all ones, so that would be 255. Second octet, all ones, so that's 255. Now, let's see about the third octet, since there were differences. I've got 3 ones, 5 zeros. Remember our column heading, we're saying 128 plus 64, which is 192, plus 32, that gives us 224. So the subnet mask has a 224 in the third octet. That is how we can optimize the use of our subnet mask by the way we use the term network address. Oftentimes the network address is where we have just the network bits set to their values, and all of set to their value and all the host bits are set to zeros. A network addresses is where the network bits are present. Whatever the network bits are, in this case, is one bunch of zeros, 101, 01, 0000000. There are the network bits, and that equals 192. 192.168.0. In those first three octets, if we set all those host bits to 0, like we've done here, we put the last 13 bits to 0. That gives us a network address of 192.168.0.0. There's also a directed broadcast. Remember what a broadcast was? We went over that a couple of days ago. It went to everywhere within a subnet. So if I went to 255.255.255, that will go everywhere within our subnet. What if we wanted to go everywhere within a different subnet? Well, we're going to discuss that tomorrow on part 3. Just keep on studying, go over the CCNA book, and I wish you well. Thank you for listening.